You probably have already seen how to find the area of a region in the plane that's bounded by two curves. What we've seen is that we want to find the top curve, so let's say f of x is the top curve and g of x is the bottom curve. And once you've determined the intersection points of those two curves, it's pretty straightforward to say the area would be the integral of the top one minus the bottom one dx, and x goes from a to b, where a and b are the x coordinates of the intersection points of the two curves. But let's take a look at this problem that I gave you here. The region bounded in the plane by x equals 4 minus y squared and x equals y minus 2. We have a line and we have a sideways parabola. So there are two things that are a little bit disturbing about the sideways parabola. First of all, that equation does not define y as a function of x, and you can see this easily because the graph fails what? The vertical line test. That graph fails the vertical line test, so it's not a function. I can draw a vertical line here and it crosses through my graph in more than one point. If you, let me get rid of that. Okay. The other problem is that if you look at the area on the right half of the plane, this area right here, it's a little hard to see, or impossible really, to determine which is the top curve and which is the bottom curve. So what we're going to do is we're going to, rather than integrate with respect to x, rather than use dx, we're going to look at this whole graph from a kind of sideways perspective and think about the independent variable as being the y. So take a look at little rectangles going this way, and let's focus in on just one of them, and we'll call that an elemental strip. Elemental strip. The area of that strip is the x coordinate at the right endpoint minus the x coordinate at the left endpoint. So it's 4 minus y squared minus y minus 2. That's the length of the strip, and the width of the strip is delta y. And if we add up all those strips and take the limit as the delta y goes to 0, what we end up with is an integral with a dy instead of a dx. 4 minus y squared minus y minus 2 dy, and since we're integrating with respect to y, we need to find the y coordinate of this intersection point and the y coordinate of this intersection point. So take a minute now and set these equal to each other and find the two intersection points. Pause the video and figure that out. Okay. So welcome back. You should have found that the two intersection points are -5, -3 and 0, 2. Since we're integrating with respect to y, the y values go from -3 to +2. Whatever variable we put over here in the dx or dy, that's the variable we use for the limits of integration. And now you can plug this into your calculator and find that the area of that funny shape between the sideways parabola and the line comes out to be 125/6. So integrating with respect to y instead of with respect to x just means that we're viewing our rectangles as going horizontally instead of going vertically, and everything else works exactly the same way.